Hello guys, now we are taking the next part of this series, integration by substitution. This is part 4. So we are taking the questions, and the question is integrate cos 2x divided by sin x plus cos x whole square. So right now we have the numerator with angle 2x and the denominator with angle x. So we should change this, either it should be x or this should be 2x. So we can modify this. So it is cos 2x divided by, we open this, that is sin square x plus cos square x, and this is 2 sin x cos x. And this becomes 1. So we have cos 2x divided by 1 plus sin 2x. This is the formula of sin 2x, and this is 1. Cos square x plus sin square x equals to 1. So right now we have numerator and denominator both in double angle, and if we consider 1 plus sin 2x as t, then on differentiation we get twice cos 2x dx equals to dt. So the value of cos 2x dx, which is in numerator, that will be half dt. So it becomes 1 over t, because we consider this as t, and the cos 2x dx is half dt. It means we can change it as an integration of 1 over t dt, and this is a standard function. So 1 over x dx so the integration of 1 over x is log x. So right now we integrate 1 over t with respect to t, so it becomes log t, and we place the value of t 1 plus sin 2x. So answer is 1 plus half of log of 1 plus sin 2x. So this is the answer of this given question. Now next question. So the next question is, it is kind of a similar question, but there is slightly difference. So we have cos x minus sin x over 1 plus sin 2x. Again the same situation, but in reverse manner. Right now numerator in terms of angle x and the denominator in terms of 2x, double angle. So we will try to make it in terms of x. So it is cos x minus sin x, and we can expand as a 1 as a sin square x plus cos square x, and sin 2x as 2 sin x cos x. So it is very easy, and numerator as it is, but denominator we can change it as a cos x plus sin x whole square, or you can say sin x plus cos x whole square. Now we substitute this denominator. Let sin x plus cos x as t, So on differentiation we get cos x, and the differentiation of cos x is minus sin x, dx equals to dt. So it is, this value is dt, and the assumption is sin x plus cos x t. So this is t, so we get 1 over t square, and there is dt. Right now this is t raised to a minus 2 dt, so we use the integration of x to the power n standard formula, that is x to a n plus 1 over n plus 1. So it becomes t raised to a minus 2 plus 1 over minus 2 plus 1. This is 10 raised to a minus 1, and this is minus 1, so we get minus 1 over t. It means it is minus 1 over we substitute the value of t. So this is the final answer. Now next question, that is integrate x into sine cube x square cos x square dx. Right now we assume sin x square as t. So on differentiation we get differentiation of sine is cos, so it is cos x square, and the differentiation of x square is 2x, dx equals to dt. So it is x cos x square, dx will be half dt. Now we rearrange this. This is sin x square cube, and this is x cos x square dx. So we assume sin x square as t. It means this becomes t cube, and this part x cos x square dx is equivalent to half dt. It means we have the expression t cube dt. So we use the formula, power formula, that is equivalent to x to the n plus 1 over n plus 1. It means the integration of t cube will be t3 plus 1, means t to the power 4 over 4 plus c. It means it is t4 over 8, and the value of t is sin x square. So it is sin x square to the power 4 divided by 8 plus c. So it is the answer. Now the next question, integrate under root of e to the power x minus 1 dx. This is important question. So let e to the power x minus 1 as t square. We can solve under root also when assumption equals to t square. So this becomes t square under root, and the value of dx, for this we will differentiate this. It is e to the power x dx is 2t dt. So dx equals to twice t over e to the power x dt, and the value of e to the power x from this expression will be e to the power x is t square plus 1. So we can put this value, and collecting the value of dx, it is twice t over t square plus 1, and we put this value in place of dx, that is 2t over t square plus 1 dt, and this becomes t. it means we have t square over t square plus 1. So right now we have the same degree in numerator and denominator. So method is first divide this, or you can some manipulation, like we can add 1 and subtract 1. So it becomes, when you separate this with LCM, so we get t square plus 1 over t square plus 1, and this is minus 1 over t square plus 1. So right now this becomes 1 minus 1 over 1 plus t square dt. And when we separate this, now both integration right now in standard form, so we can directly place the answers. So it is t, and this is twice of tan inverse t. And we put the value of t. T is under root of e to the power x. So we put this value in place of this. We get twice of under root e to the power x minus 1 minus twice of tan inverse of under root e to the power x minus 1 plus c. So this is the answer. Now next question. It is x plus 1 into e to the power x over cos square x ex. Now we consider this angle of cos as t. X into e to the power x is t. Now on differentiation we get we use the product formula. Differentiation of x is 1, e to the power x as it is, plus x as it is. The differentiation of e to the power x is again e to the power x, dx equals to dt. So on taking e to the power x as a common, and we get x plus 1. So this is the substitutions, these two substitution. We put these substitution in this question. So the numerator is this, so we can place dt in place of numerator, and the angle of cos square is t. So we get sec square t dt, that becomes tan t. So this is the answer, that is dx over x minus root x. So we rearrange this, and we will take root x as common. We get root x minus 1, and this is dx. Now we can consider root x minus 1 as t, or you can consider x as t square. So it becomes 1 over 2 root x dx, and it is dt. So right now we have 1 over root x minus 1, and this is 1 over root x dx. So we put these two values. Right now this is t, and in place of this we have dt. It means we have the result log t, and t is root x minus 1. So we put this. There is a little bit change due to this too. So when we consider root x minus 1 as t, the differentiation is this, and we rearrange this, the value of this is twice dt. 1 over root x dx is 2 dt. So we place twice dt. So 2 will be common. So as a result, 1 over t dt is log t. So the final answer is twice of log of under root x minus 1. So the next question, this is important question. Integrate x to the power half plus x to the power 1/3. So we have the fractional powers. To solve this type condition, we will consider x as t to the power LCM. The LCM of 2 and 3 is 6. So we consider this. Right now dx equals to 6t5 dt. So we will place x as t to the power 6 half plus t to the power 6 1/3, and in place of dx we will place 6t5 dt. So this becomes, in denominator it is t cube plus t square, and there is t5. You can break this t cube and t square dt. So it is, when we will take t square as common, we get t plus 1, and there is t cube and t square dt. So this one will be cancelled out, and right now we have t cube over t plus 1. So right now the degree of numerator is higher than denominator, so we go for long division. So it is t cube, and we will add 1 and subtract 1. So it becomes t plus 1 and t square minus t plus 1, and this is minus 1. So we can manipulate like this also. So it is 6, this one will be cancelled out, then you get t square minus t plus 1 and minus 1 over t plus 1. So on integration we get 6, this is t cube by 3 minus t square by 2 plus t and minus log of t plus 1 plus c. Now we can substitute the value. So right now on putting this value, t is x, t equals to x to the power 1 over 6. So this is the value. When we put this, we get, this will be cancelled out, you get 2, and this is root x. You will collect half power, this is cube, and this is 1/6. So you get 1 over 1 by 2, that is root x. Same way, when we place this, and we get 1/3. 1/3 means cube root. So it is 3x 1 by 3. This will be cancelled out, you get 3 1/3. There is x to the power 1 by 6, and this 6 is also multiplied, and 6 log x to the power 1 by 6 plus 1 plus c. So this is the answer.